In this video, we're going to talk about how to graph a polynomial function. So I'm giving you a polynomial function that is already in factored form. So you notice how you don't need to factor this polynomial function, it's already there. I'm also listing all the various different things I want us to find, the properties, you might say, of the graph. So I want to find the Y-intercept, X intercept, maximum turning points, behavior at each X intercept, and also end behavior. That's a lot to find, so we're going to piece it together one by one, and hopefully by the end of it we'll have a pretty clear idea of what the graph looks like. Alright, so let's start with the Y-intercept, and the Y-intercept we're going to substitute 0 for our x's, and that will produce the Y-intercept. So f of 0 equals 0 minus 2 quantity squared times 0 plus 2 times 0 plus 4. Alright, and when you do that, you should get 32. So the Y-intercept is 0, comma 32. Okay, the X-intercept, you're going to take the f of x, you're going to substitute 0 for f of x. So 0 equals x minus 2 quantity squared times x plus 2 times x plus 4. Alright, from those factors, you're going to then find the three X-intercepts. So the X-intercepts are going to be 2, 0 from the first factor, negative 2, 0 from the second factor, and finally negative 4, 0 from the third factor. Okay. Now we want to talk about whether these the graph touches or crosses at these X-intercepts. All right. So what I do is I look for the multiplicity, and what you're really doing is looking for the exponent of the binomial. So for example, x minus 2 is a binomial being squared, which means it has a multiplicity of 2, which means it's an even multiplicity. And if it's an even multiplicity, it touches at that X-intercept. These two binomials have a multiplicity of 1, which means that they cross at each of these. Okay, so they cross at negative 2 and negative 4 and touches at positive 2. All right, maximum turning points. So maximum turning points, you're going to first have to find the degree. And we might as well, while we're at it, find the power function. So what you can do is kind of visualize what that leading term would be if you were to multiply everything out. So the leading term after you were to square this binomial here would be x squared. Then times that by x and times that by x, and that would produce x to the fourth. I'm actually going to put it down here under end behavior because that's what we'll want for the end behavior, is the power function. Now because the coefficients are all 1s in front of all of these x's, it's just simply 1 squared would be 1 times 1 times 1, so it's going to be 1x to the fourth, or just simply x to the fourth. Now for maximum turning points, remember you're going to take n minus 1, which is in this case 4 minus 1, which is 3. So there's a maximum of 3 turning points. There could be fewer, but there's a maximum of 3. Now we're going to look at behavior at each X-intercept. So let's start with at x is equal to 2. So for x is equal to 2, you are going to substitute 2 into each factor except the one that produced the 0. So in this case, you'll have x minus 2 quantity squared, because that is the factor that produced the 0. And then you'll have 2 plus 2 and 2 plus 4. And so when you do this, you should get f of x is equal to 24 x minus 2 squared times x minus 2 quantity squared. All right, now I'm going to erase this, and I'll rewrite them, the final answers, when I'm all done. But that's the first one. We have 2 more to go. So the second one, we have at x is equal to negative 4 rather. So you'll have f of x is equal to parentheses -4 minus 2 squared times -4 plus 2 times x plus 4. From here, again, do your order of operations to figure out that it will be f of x is equal to -72 times x plus 4. Okay, so that is your second. At x equals -4, that is your behavior. Again, I'll rewrite this. Finally, at x is equal to -2, you're going to substitute for all binomials that did not produce that 0. So it'll be -2 minus 2 quantity squared times x plus 2, because that produced the 0, times -2 plus 4. All right, and when you do your order of operations to simplify, you should get 32 times x plus 2. Now that we have all the information listed and we have a coordinate plane off to the right, notice here my scale, I changed it ever so slightly, which is why I put a grid on there initially. Notice the horizontal axis, in other words the x-axis, I am going every other unit block is 1, so in other words my scale is 1/2. And I did that to spread it out because it looks like all these points are fairly close and clustered together horizontally. And the vertical axis, I did shift it so that way, or adjust the scale to 2, but I only marked every 4 units. Again, because otherwise it'd look very clustered if I were labeling every single block of 2 units. So it is going by scale of 2, but I only marked every 4. Okay, so let's go ahead and graph this, and I'm going to start with the y-intercept, which is at 0, 32. So it's all the way up here at 32 on the y-axis. Sorry if you can't read my writing there. And I've got 3 x-intercepts. I'm going to start with 2, 0, so that would be right here. I've got -2, 0 right here. And I've got -4, 0, so right here. All right, some more information here. I know that the behavior, so I know whether it's going to touch or cross each of these based on what I have over there, but let's talk about the behavior and how it touches or crosses. So at -4, notice it's going to cross. It's actually going to be decreasing fairly sharply, in fact. Okay, and I know that because of the -72 and the fact that it is linear. +32 means it's going to be increasing through this point, and it's going to be increasing again somewhat sharply, and because it's a pretty sizable or high slope. And then at +2, I know that it's touching. I know that it's touching with a small parabolic curve, and I know because of the +24 that it's actually going to be opening up. All right, this power function tells me I know the end behavior, and the end behavior is going to be opening up, and it's going to be decreasing on the left side, increasing on the right side. I might fill in some points here to make that more accurate, but that's kind of the general idea. And I know that it's going to be opening up because it has a coefficient of 1. If it were negative, it'd be opening down. So in other words, it'd be increasing on the left side and decreasing on the right. All right, now notice here I'm missing some points, and I really would like to have some more information to figure out what the shape of this curve really is, keeping in mind that there are a maximum of 3 turning points. So I'm going to pick 3 order pairs. I'm going to pick starting with -3 because I'd really like to know what's happening between these 2 intercepts. I'm then going to pick +3 because I'd like to know what's happening slightly to the right of the last intercept. And I'm going to pick -5 to know what's happening to the left of the first intercept. The -3, and this one's really important, is going to be an output of -25. +3 will be an output of +35, and -5 will be an output of 147. So I will not be graphing that ordered pair. However, it gives me an idea that -5, it's off the chart. So it's going to be pretty, this is going to be increasing, or actually decreasing very steeply. So I'm going to go ahead and make this one. Again, I apologize for my terrible curves, my horrible drawings. I'm going to erase my other arrow, so that way I only have one. That should be smooth, and it's obviously not. At -3, I'm down 25, so I'm going to go down to 25, which is about right here. So we should be curving down through this point and up through that point. up through the X-intercept at -2. Then we have the Y-intercept at 0, coming back down through the first intercept on the right-hand side. And then I have a third point that I did plot. I did check to see +3, and it is at +35, so I'm going to go ahead and plot that one just so, again, I have a slightly more accurate graph, and that point is right about here. So my initial estimate was somewhat close. So we have the curve coming up around like that. Sorry for the horrible smooth curve there, but you get the idea. So that is how you graph a polynomial function, and that's why we need all of that information. It's a lot to comprehend. It's a lot to process on all the information that we need for this one graph. But anyway, we need the Y-intercept, the X-intercept, the turning points. See, we do have 3 turning points, one here, we have another one here, and we have a third one right here. And the behavior did help give us an idea of what was happening through those X-intercepts. End behavior told us kind of where it's increasing and decreasing on the ends. And finally, we did have to use this t-table to figure out some missing parts. And you know what? The more points you include on that, the more accurate your graph happens to be. So good luck. Let me know if you have any questions.